Okay. Hi everyone. Welcome back. Today is day six. Day six. So today is January 21st, 6:50 p.m. It is a Tuesday today, and today we'll be looking at day 15 of Advent of Code 2024 Warehouse Woes. Let me make sure I'm not muted. All right. You appear back inside your own mini submarine. Each historian drives their mini submarine in a different direction. Maybe the chief has his own submarine down here as well. You look up to see a vast school of lanternfish swimming past you. On closer inspection, they seem quite anxious, so you drive your mini submarine over to see if you can help. Because lanternfish populations grow rapidly, they need a lot of food, and that food needs to be stored somewhere. That's why these lanternfish have built elaborate warehouse complexes operated by robots. These lanternfish seem so anxious because they have lost control of the robot that operates one of their most important warehouses. It is currently running amok, pushing around boxes in the warehouse with no regards for lanternfish logistics or lanternfish inventory management strategies. Right now, none of the lanternfish are brave enough to swim up to an unpredictable robot so they could shut it off. However, if you could anticipate the robot's movements, maybe they could find a safe option. The lanternfish already have a map of the warehouse and a list of movements the robot will attempt to make. The problem is that the movements will sometimes fail as boxes are shifted around, making the actual movements of the robot difficult to predict. Okay, so here's the map and the robot's movements, up, down, left, right. As the robot @ attempts to move, if there are any boxes in the way, the robot will also attempt to push those boxes. However, if this action would cause a robot or a box to move into a wall, nothing moves instead, including the robot. The initial positions of these are shown on the map at the top of the document the lanternfish gave you, okay? The rest of the document describes the moves that the robot will attempt to make in order. The moves form a single giant sequence. They are broken into multiple lines just to make copy and pasting easier. Okay. Here's a small example. So boxes are O's, walls are hashtags. Okay, so when you move left, it won't move. When you move up, it will move. When you move up, it'll move. When you move right, it pushes the box. If you move right again, it pushes all the boxes. Okay. Okay, so I think I understand the problem. Alright, so what do we need for the answer? Okay, so we essentially need to get the final warehouse and then use the GPS coordinate thing to get the answer. So this part should be pretty trivial, but the hard part is moving the robot. Okay, so I think just moving the robot left, down, upper, right is really easy, and then if there's a hashtag, then don't do anything. The trick is with a box or chains of boxes. So, okay, so if you have a robot and you have a box and you have an empty space, the robot becomes where the box is. So if a robot moves into a box, there's two situations. So situation one is like the box is pushable, and the other situation is if it's like not pushable. So, and you know it's not pushable if one or more, like a chain of boxes, is then a wall at the end. That's the only scenario where you can't push a box. So that would be like right here. It doesn't actually, yeah, right here when you move right, you're pushing the boxes into the wall. So I think we have to use some sort of while loop. Yeah, I'm just thinking how we would. So that's kind of the hard part of the problem. Is pushing a box. So if I'm thinking about how we're pushing the box, and then so let's just do it from left to right, and then the logic will probably apply in all directions. Still not muted. Okay, so if we have like a box here and a box here. Okay, so let's say you want to move right, and you have positions. Let's just imagine it's a 1D space. Okay, so you check I here, and you say. So I wonder if you can do it into two parts. Like first, check if pushable, and if it is pushable or movable, I guess is probably what people say. So check if it's movable, and then if it is, then move it, and if it's not, then don't. So to check if it's movable, you say while like let me move this over. While grid of I equals a box, I plus equals 1, or whatever direction, right? So I plus equals 1. And then when it's no longer a box, you check what it is. So the final, or what's at the end, so like end of the chain is either, so it equals grid of I, and that's either going to be a period, that's what it is, right? A dot, yeah, dot, or a hashtag. So if it is a period, then return true, so it is movable. And if it's a hashtag, then return false. Okay, so this is the check movable function. It's going to be like that, except in all 4 directions. And then we want to have another function called, I guess, like move chain. So I want to think if there's a shortcut. Like we might not actually have to move every box, because if you have a robot and then let's say 3 boxes and then this, the end result should be dot robot box box box. So everything in the middle, so if this is like position 0 1 2 3 up until n, so the only things that change are positions 0 1 and n. So we can just say so like 0 becomes dot, 1 becomes robot, and then n becomes a box. And boxes don't slide or anything, right? Like it just moves exactly 1 over, right? So left, up, up. Yeah, so this would be, so this while loop would go until it hits the dot, and then we would move it. So 1 would become dot, this would become @ sign, and this would become box. And that's what happens here. So dot @ sign box. Okay, so I think I'm ready to start with coding here. And then obviously there's the GPS thing, which we can figure out after. That's not what I meant to do. Okay, there we go. So first of all, we need the grid. So I'll represent this as a 2D array, obviously, and then this will just be a list of characters, which are the moves. And that'll be in test in, actually. Okay, so So I'll just call it chain is movable. And this will take in the well, it's gonna return a boolean. Is that not how you do it? So this needs to take in probably just a grid. So the grid, the robot position, and the direction that it is pushing in. And I think that's it. Okay, and then to move chain, it takes in a grid, robot position, chain length, which this function could also return the chain length. Do we need? We probably do want the chain length. Okay, so I'll just return integer. So calculates chain of box length as and if chain is movable. Why is it mad? Indent, okay. So it takes the chain length and it will return a new grid, which is a list of lists of characters. All right, I don't know. I should look in how to do that. Then I'll just say returns bool int. All right, still not muted. That's good. So this will update the grid to reflect box push and returns new grid. Or I guess it doesn't. Yeah. Can you say like void? None. Okay. I'm not going to include that, but okay, so updates. No return value, okay. Okay, so let's read the input here. So warehouse woes dot test dot in. So we want grid, which is a list of lists. Obviously, it's just a characters list of characters, and moves, which is a list of moves. Pretty self-explanatory. I don't think I need to add those. Okay. All right. So let's see what this gives us. Python. Where? Typo. Woes. Okay. So if I split it by a new line, that will probably do this. I think I'll read every line. So for line and f dot read lines, and then if the line is an empty line or if it's just like a new line, then we'll start reading into the other one. Actually, we don't have to do that. I could just say if the first element of the line is a hashtag, then we know that we're reading the grid. So we can just say grid dot append a list of that. So let's print grid and see if that worked. And then we also would like to split each line. Okay, looks good. And else, so our data is just going to be one line. So the problem with this is it might, I think it'll be fine. Yeah, it does work, but I think what's happening is this is being established as moves and then this, but it's fine because it's just getting overwritten. Okay, so we have our data how we want it. Okay, so I will say read data. Okay. So I guess we also want a function just called move robot, which will update grid. And it has no return value. So this will take in the grid and the robot position and a move. Okay, so first, so what's robot position? Oh, we need the robot position. should I just do it like this? Or I basically just need to get the at position. It's probably better to just do it here. So each line is this. So we could just say while I is less than length of line. So we can say I equals 0. If if line of I equals @, then robot position equals line num, so that's like the row that it's on, and then I. Okay, let's see if that gives me an error somewhere. Two. 0, 1, 2, 0. Okay, perfect. Let me see what happens if I put it here. Row 2, column 3, perfect. Okay. Still muted? Not muted? All right. Okay, perfect. So now we want to move the robot. And let's say we use moves of 0. Okay, so first we want to check if the robot, so we'll say bounded is it will take, so I want a function basically that takes in the grid. Well, it'll take in 2 values. So I don't remember the syntax of this. So this will, I don't remember how to do this. Okay, so what do I want? So first we have to see what move is. So if move, we'll do clockwise, I guess. If move right, down. How do I do a down arrow? Oh, V. Left. Okay, so we want to check if it's bounded. So let's just say row column is robot position. Okay, I think I got it. So it will return. So this will either be true or false. So if R, if grid of R minus 1, so row minus 1, column equals this. So if it is equal to that, we are not bounded. So we want if it's not equal to that. Well, I guess we need to know what character we're bumping into. Okay. I guess we could say like step. So if you go, so step would be go up a row. Yeah, okay, so we'll do this for each of them. And then we can use that. So if it's to the right, then you don't change the row and you go one column over. And if it's down, then you go 1, 0. And then to the left is 0, -1. So these two both don't change the row, and these two both don't change the column. Okay. I guess what we might want to say is like new position, and then it would be R minus 1 C plus 0. No, I guess we could just say new position equals R plus step of 0, and then column plus step of 1. Alright, let's see if this is working. Okay, it seems that moves is different from what we think, so let's see. Okay, so this is the easy part of the code, so I should probably... Okay, so moves... Moves is just a list of a string? Oh, I guess that makes sense. Yeah, we can't split the line. So we just want to say that. Okay, that makes sense. Okay. Perfect. Okay, so I would like to print old position equals robot position, and then new position okay, so we move once to the left. Alright, so I'll just say for I in range. So let's just look at the first couple moves. make sure it's working properly. So 2 2 to 2 1, 2 2 to 1 2. Oh yeah, because it needs. Okay, well, so this one went. So the first moves are left, up, up. So left means same row, 1 minus column. And then up means, okay, yeah, so it seems to be working. Okay, so new position. And now we want to get, so we could say like, obstacle equals grid of new position 0 and new position 1. Alright, and then if obstacle is this, then we'll just say robot position. So alright, this is, I don't really like this. I guess I could say like new x, or like new is r plus step of 0, and then new column is column plus step of 1. Alright. New row, new column. I'm just going to call it like that. Alright. If obstacle is that, then we say grid of. So we want to swap it essentially. So grid robot column. So this is where the robot was. Still not muted. Okay, good. So the robot was, where the robot was, we're going to make a period. And where the robot is now, we will make a @ sign. Maybe this should return. Should probably return the new robot position as well. Maybe it should be recursive. Okay. If the obstacle equals a hashtag, then do nothing basically. If the obstacle equals a box, it is an O, right? If it equals an O, then we will is movable equals chain is movable, robot position and direction. So I'm wondering if we should just, instead of move, we should pass I and then say move equals moves of I. And then every time we call this function again, so we could just say move robot. It takes grid, and then instead of passing robot position, we'll pass new row and new column, moves, and I plus 1. And then if I is, and then we want to stop when I is greater than, or when I is greater than or equal to length of moves. because that would give us out of bounds. Okay. If it's a wall, then we want to just return the position it's already in instead of a new position, and we don't want to do anything there. Okay, so if it's... Okay, so now we want to check if it's movable. So we could just pass in step here. How are we doing on time? 36 minutes. Okay, not terrible. Still have a lot of the code left though. Okay, so before I do that, let me just try this. Where I move robot grid, robot position, 0. And then at the end, I just want to print the grid. So let me try this. So before we worry about any of the boxes, I'm just going to treat it as a wall. What is happening? So I'm just going to treat it as a wall and make sure everything's working so far. Okay, that's not good. Out of range. It should always be bounded because the hashtags go along the surface. Okay, so we're at 2.2, and then get to line 50. So let me just print new column and new row. One, two. How is that out of range? Should not be out of range, so let me see what grid is. Okay, well, grid I actually want to be... Right now it's just a list of lists, but each list is an element that contains a single string. Did I mean to do dot strip, but I did dot split? I think that's what happened. Okay. So, and then I also just want to print the move. Alright, so let's just look at this and see if it's working so far. So we're at 2.2, we move to the left. And let me get rid of grid, that's not working. Okay, so we move to the left. We don't upgrade the grid yet though. So let me print the grid up here. Okay, so we start here, then we move into a wall so it doesn't do anything, then we move up, then we move to the right, doesn't do anything, then we move to the right, doesn't do anything, then we move to the right, doesn't do anything, then we move down. Okay, that worked. Then we move to the left. So that moved me down again. Did it? So here's the grid. We're at 2, 2, and the move is down. Okay. And then here the move is left. Okay, so it looks like it's working, so that's good. Comment that out for now. We're at 41 minutes here. Okay, so now I want to check if the chain is movable. Okay, so first of all, the first box and direction is what? Just step? Yeah, I'll call it step. So first box is basically equal to grid. I'll just say step x equals step of 0 and step. Grid of r plus step x and column plus step y. Alright, so pretty much the same as we did with the obstacle up there. So that's the first box. So we want to see, like, keep going until there is no box. Okay, so set. We just set I equal to 0. Alright, so I think what we want to say is while, so we could say like check position is this. And then we want to multiply it by I. I think. So for instance, if it's to the right, then that would mean row does not change and column changes by 1. So first we want to check row plus 0 and then column plus 1. And then we want to check row plus 0, column plus 2. And then row plus 0, column plus 3. So that's, that can be defined as row plus step x times I. The only problem is, I guess I can start at 1. So you're not multiplying it at all, or you're multiplying by 1, which does nothing. So this, because one of this will be like 0, for instance, and this will just be times 1. So okay, checkpot is always going to equal O because we already checked it. Okay, and then I guess we increment I by 1 first. And then calculate the new. Okay, so eventually check position won't equal, so we'll say like end obstacle equals check position. So it will not be okay, so if end obstacle is a hashtag, then return false. I guess we can just return if end obstacle equals a dot. Okay, so now this should just give us, it's not going to really do anything yet. It's not updating the grid at all. Yep, that makes sense. Okay. I did it again somewhere. Here. We don't need this variable actually. Okay, so because it's not updating the grid ever, it's always pushable. Because push, push, push. Yeah. All right. Okay. So I think that part seems to be working. So now let's say movable. If movable, oh yeah, and this also returns a, yeah, so we want to return this and I. So let me just print this and see what it says for the first one to see if I need to plus or minus it by 1. 2. So it says 2. So I think we have to minus it by 1 because it's gonna fail here. Yeah, all right. So true, it's pushable and a length of 1. Perfect. So then what we want to do is like that. So if it's movable, then we want to move the chain. And then if it's not, and then what does move chain need again? Grid, robot position, and chain length. So it'll update the grid. And then also we need to update the robot position as well. So we have to do this. Actually, that'll be take care of, but we need to, when we pass it again, so when we say move robot grid, then it has to be new position. So I think we do this here. And if it's not movable, then we do the same thing as if it was a the chain is not movable, don't do anything. If chain is movable, update grid. And call next iteration with new robot position. Okay, so move chain. Yeah. So move chain, I want to and I also need step. This problem is hurting my head. I think I'm doing a good job. It's just a lot. It doesn't seem like it would be that hard. Okay, so move chain. Okay, so we want to all right, so first of all, grid of RC is going to be equal to that for sure. And then grid of R, all right, and then what did I call it before? Step X and step Y? Yeah. Step X. So you can think of this as just a new position. Still not muted, great. Column plus step Y. It's not really X and Y, but okay, so the new position is the robot. Okay, and then all the other positions are the same except grid of R plus step X, C plus step Y equals O. So we're making the last one. So I think we just multiply these by chain length. And we might have to add a 1 to those. So let's think. So, okay, so in this example, chain length is 3. So we say this one becomes a dot. The one that we're going to be at becomes an at. So step Y is 0, or no, it's actually, that's 1. We're not changing in the horizontal, in the vertical direction. So this evaluates to R plus 0, so it'll stay the same row. That's what we want. Now this evaluates to the column we're in plus 1 times the chain length. So the column we're in plus 1 times 3. So our column 1, 2, 3, and I think it's plus 1. Okay. Let's see if that gets me any errors. Let me just print. Where's my main function? Let me just print line for line in grid. See if that looks right. Alright, it doesn't. Because this here there's 4. But here there's 2. Okay, let me do this at every step, I guess. And see what happened. Alright, so the first step's good. Moves to the initial state moves to the left, moves up, moves to the right. Oh, there's 2 ups. Oh yeah. Moves up, moves to the right. Looks great. Moves to the right again. Looks great. Moves right again. Doesn't do anything. Move down. Looks good. Move down again. Looks good. Move left, so down, down, left. Looks good. Where was I here? Move down. Move right. Still looks good. Move right again. Move down. Move left. Still looks good. Move left. Still looks good. Oh. No, it actually looks good. Oh, okay. Oh, great. Okay. Looks like it's working. Alright, let me try it with a larger example and compare. So, the larger example. That's different. Okay, so let's just look at it, see where it goes wrong. This could be a lot faster. If we see any unexpected behavior, okay. So we start here, move down, move up, move up, move right, move right. So we push the box. Move right, it's fine. Move left, it's fine. Move left is good. Move up is good. Move up. Move left, good. Move right, good. Move right, good. Move up, good. Down, good. Up, good. Left, good. Down, good. Up, good. Down, good. Down, good. Left, good. Right, good. Down, good. Up, good. Left, good. Left, good. Right, good. Up, good. Left, good. Up, good. Down, good. Up, good. Down, good. Right, good. Left, good. Up, good. Left, good. Left, good. Left, good. Right, good. Left, good. Left, good. Up, good. Left, good. Down, good. Right, good. Left, good. Down, good. Left, good. Right, down. Push it. Pushed it. So it should be here, here, and then it pushes again. Wait, is this a problem? So it pushes it, so it goes @ here, and then it moves down. I think that's fine. Moves to the right, moves to the right. It's down. It looks good. I don't know what's the problem. Am I missing the last move or something? Okay, so it's a bunch on the top. I have none on the top. Is it a different example? Am I reading the moves incorrectly? Oh, is that what it is? It might be. let me get rid of these prints. I think it looks good, but maybe I just didn't read all the moves. So let me get rid of some more prints. Okay, what is printing out? Okay, 70. This looks like more than 70, right? 4. How many lines are there? 1, 2, 3, 4, 5, 6, 7. Yeah, this is definitely more than 70. So each line is 70. Yeah, I think it has something to do with this. Okay, so each one is 70. Yet, oh, I think we want to say moves dot append. Okay, so the first one is empty, which is a problem. Okay. So I don't really want it to be so did I say moves? Okay. I think that matches. Not muted still. Wow. Awesome. Okay, it looks good. So it looks like it was working the whole time. It was just the way I was reading the input was incorrect. Okay, so let's assume we have the correct grid. Um, so now calc GPS, I'll just say calc score. Just takes just the grid. Okay, so let me see how they calculate it. Okay, so for every box. Okay, so it's so it's 100 times its row plus its column. Okay. Um, okay, almost done. So let me just print IJ here just to make sure. Alright, I'm unmuted. I don't know how long I was muted. How long are we looking at? An hour and 20. Okay, almost there. Move robot grid. Well, we don't want to call it again, actually. We just want to... So it updates the grid. And then... That's all it does. Okay, so then we just want to return new R, new C. That's the new robot position. Here we basically just want to return robot position. Same here. Okay, let's see if this works. Alright, before we do that, let's verify that the grid is still functioning. Why is it like that? Oh, because I'm doing that. Okay. So test is this one. Let's do this. Okay, so it seems like something's off. Let me print moves and make sure it's still working. So it has to be something with what I just changed. So let's see that. Yes, so this is not right. Alright, so let's look. Oh, do I not set I? Okay, does it give me the score? Oh, it just gives it for this one. Okay, let's try it with this one. I think that was the problem. I was starting at a different value, so I started with the wrong moves. Alright, and if I want to calculate score for that. Okay, there we go. Alright, let's try it with the real. That doesn't look right. With this. Okay. Alright, let's try this. Okay, we got it. Alright. Thanks for watching, everyone. That was an hour and 20 minutes. That wasn't bad. I feel like I feel like that problem was pretty tricky, actually. Yeah. And also that, I guess a lesson from that is don't do recursion if you don't have to. Yeah, so don't do recursion if you don't have to, or else you'll get the recursion limit. Everything else I feel like went pretty smooth. Reading the input maybe with moves, I kind of messed up a little bit there, and it was causing some bugs. But other than that, that was pretty good. That was a pretty hard problem, so I'm happy I was able to do it. So thanks for watching, and I'll see you tomorrow.